Hey everybody, in this video we're going to be solving a quadratic equation by completing the square. And so far we've looked at solving quadratic equations. Remember that solve means we're just looking for the x-intercepts, the roots, the solutions, the zeros, whatever you want to call them, because they have about 40,000 names. But in any case, we're just looking for the places where the graph of the function crosses the x-axis. So we can see the solutions here are x equals 1 and x equals 5. But the thing that's different is in the past we've learned how to do this from vertex form, we've learned how to do this from intercept form, and now we're looking down the barrel of standard form, and we want to know how to make that happen. So as with so many other things in mathematics, we're going to make this happen by taking something we don't know how to do and changing it into something we do know how to do. So the thing that we do know how to do is we know when I have an equation of the form something squared equals a number, think vertex form here, we can solve it by taking a square root. And just to satisfy you that this is actually the case, if I look at this particular problem, 2 times quantity x minus 3 squared minus 8 equals 0, this has the general form of something squared equals a number, so I can solve it using a square root. So to start out with, I would add 8 to both sides, leaving me with 2 times x minus 3 squared equals 8. And this is, again, just solving out of vertex form. Nothing you haven't seen before. Then I'm going to divide by 2 to get rid of that coefficient. And I get x minus 3 squared equals 4. And notice this is purely that situation we were talking about. Now I have something squared equal to a number. And I can solve that by taking a square root, remembering that the square root undoes the squaring, leaving me with just x minus 3 on one side. The square root of 4 is either plus or minus 2, and so I'm going to add 3 to both sides. So x is equal to plus or minus 2 plus 3, and I can split that off. If it's positive 2 plus 3, x is equal to 5, and if it is negative 2 plus 3, x is equal to 1. And so those are my two solutions, which is kind of what I expect. And if we look back at our graph from the previous slide, we can see that, oh, that was just vertex form for that exact same equation. So we know how to do this. This is no mystery. I just wanted to remind you of it a little bit. So now what we're going to do is we are going to take an equation that is in standard form and make it look like that problem that we just solved. Because once it looks like the problem we just solved, we know how to solve it. That's something we can already do. And this process of doing this is called completing the square. So we're going to take our standard form equation that we saw from that very first slide, and we're going to complete the square. And here are the steps for that. And as we go through this, you need to memorize both what to do and kind of why it works. So I'm going to be tackling both of those at the same time. So the first thing we want to do is move the terms around, and there are 3 terms. This is a trinomial. There's 1 term, 2 terms, and 3 terms. Remember, that includes the sign in front of it. We want to move those terms around so that a and b are on one side of the equation and c is on the other. Remember, in standard form we have ax squared plus bx plus c. So I want a and b, my ones with x's, to be on one side and c on the other. That's easy enough to do. All I'm going to do is subtract 10 from both sides. And now I get 2x squared minus 12x equals negative 10. Now what I want to do is divide all terms by a. So a in this case is 2. So I'm going to divide everything by 2. And essentially all this does is make our a value equal to 1. And makes everything just a sight easier to work with. And so once I've divided that through, I now have a equal to 1. And steps 3 and 4 are where this gets a little magical. Because what our end goal is I want to take this side, the left side that has a and b on it, and I want to write it as something squared. So I want it to create what's called a perfect square trinomial where I have the result looking something like x plus or minus some number squared equals some other number. Now, the way I have to do this is where step 3 comes in. The number that I can add to the end of this that's going to make it a perfect square is b over 2 squared. Well, b in this case is negative 6. So it's negative 6 over 2 squared. Well, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So b over 2, and then take that value and square it, in this case happens to be 9. And so I'm going to add 9 to both sides of my equation so that I get x squared minus 6 plus 9 equals 4. And now for my final step, I can rewrite what I just made there after I've added b over 2 squared, and I will get x plus b over 2. Well, b over 2 is just negative 3 in this case, so I would say x minus 3 equals 4. And now let's stop and talk conceptually about what's happened here. I had originally this trinomial. I moved c over to the other side, so I got rid of c. C's not in the picture anymore. And I divided out by a so that a becomes 1. And then I picked the value of c that I wanted, 9 in this case, so that I could rewrite this whole side as something squared. And in fact, if you multiply out x minus 3 squared means x minus 3 times x minus 3, if you multiply that out, you'll find that it is equal to x squared minus 6 plus 9. So I've just taken this equation, think of it as a big old pile of Play-Doh, and I've just reworked it until it looks like something that I want. Now that I have it here, I can solve this, and what I need you to see is that this is exactly how we solved this problem before. If you look at this step and then look at the step we're on now, it's exactly the same. So I end up with x minus 3 equals plus or minus 2, and when I separate those out, I get x equals 1 and x equals 5. And that process is called completing the square. So what we're going to see from here to the rest of the video is just examples of what this looks like. Our first example, we want to solve the quadratic equation x squared plus 2x minus 99 equals 0. So the first thing I'm going to do is I'm going to move c to the other side of the equation so that it is out of the way. So I get x squared plus 2x equals 99. Now I want to divide by a in order to get a equal to 1, but hey, a is already equal to 1, so I don't even have to worry about that step. Dividing by 1 is not going to change anything, so I can just leave that alone. So now what I need to do is I need to find b over 2 squared to add to both sides so that I can make this a perfect square. Well, b in this case would be 2. So 2 over 2 squared is going to be just equal to 1. Well, that's simple enough. So now I'm going to add 1 to both sides of the equation, and I get x squared plus 2x plus 1 is equal to 100. Now that I have this, I can rewrite this side of the equation as x plus b over 2, so that's 1 in this case, squared is equal to 100. And now I have something squared equals a number. I know how to solve this. Square root to the rescue. And I get x plus 1 is equal to plus or minus 10. And so now I can separate this off into two distinct possible answers. It could be that x is equal to positive 10 minus 1, because I would subtract 1 from both sides. And in that case, x would be equal to 9. Or it could be that x is equal to negative 10 minus 1, in which case x is equal to negative 11. And there we have it. I've now solved this quadratic equation by completing the square. So here's another one. This one's a little messy because it has an a value that is not 1. But as is always the case, I'm going to start by separating c away from a and b. So I get 4k squared minus 16k equals 84. Now I want to divide by a. Let's get a equal to 1. So I divide everything in there by 4, and I get x squared k squared. Sorry about that. Minus 4k is going to be equal to 21. Now I need to find b over 2 squared. B in this case is negative 4. So if I do negative 4 divided by 2, that's going to give me negative 2. Negative 2 squared is going to be equal to positive 4. And so I would add 4 to both sides, and I get k squared minus 4k plus 4 is equal to 25. Now this left-hand side can be rewritten as x, and then I'm going to add to it b over 2, which is minus 2 squared equals 25. If you're not sure if you are correct in this step, you can expand that and take k minus 2 times k minus 2 and figure out if you are in fact correct. In this case we are. Now we're going to take square root of both sides. I get k minus 2 is equal to plus or minus 5. So now I'm going to add 2 to both sides. And for my two options, I get that k could be 5 plus 2, which is 7, or k could be negative 5 plus 2, which is negative 3. And so those are my two solutions. If I want to write it down all nice and pretty, I can over here. K is 7 and k is negative 3, and those are my two solutions. So there we go, completing the square. Let's look at what can happen if this is not as pretty. Notice in this one, all that's happened is that I have a number that is not 0 over here. But it's all right, because what I end up doing is still just separating this c out from the rest by adding 9 to both sides. And when I do that, these cancel. 6 plus 9 is going to be 15. Now I need to divide by a to get a equal to 1. And that leaves me with v squared minus 2v equals 3. I need to figure out what to add to this, so I take b over 2 squared. b in this case is negative 2. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I add 1 to both sides, and I would get v squared minus 2v plus 1 is equal to 4. I can rewrite now the left-hand side of that equation as v, and then I'm going to take b over 2, which is negative 1 squared equals 4. Now I'm ready to take the square root of both sides. Hopefully you kind of see how this is going. I get v minus 1 is equal to plus or minus 2. I can add 1 to both sides, and I end up with two options. Either v is equal to positive 2 plus 1, in which case v is of course 3, or v could be negative 2 plus 1, in which case v is negative 1. And those would be my two solutions. You can check this by graphing it, you can check this by substitution. There's all kinds of ways to find out if you're right, but that is the general idea. The last one we're going to look at is what happens when this is all mixed up. So we're trying to get our A's and B's on one side and our C's on the other, and here we can see I have A, and then I have C, and then I have B over there. So this is nowhere near standard form like we would like it, but we still really just need to get the B's and the A's on one side and the C's on the other. So let's start by moving B over here to be with A. And I want to point out something that happens here because I feel like you guys could very easily fall into this trap. what is happening on the right side of this equation? 12v minus 12v, it's not going to go away. We can't just write nothing there. We need a placeholder to show that it's nothing. It's 0. And then I can subtract the 35 from both sides, and I would get v squared minus 12v equals negative 35. Now I have separated A and B are on one side, C is on the other, and I can continue as usual. I need to do b over 2 squared. B in this case is negative 12. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So we've got a number with a little more heft to it this time, but it doesn't change anything. I get v squared minus 12v plus 36 is equal to 1. I can rewrite the left-hand side as v plus b over 2. b over 2, of course, is negative 6. Now I just take the square root of both sides. So v minus 6 is going to be equal to plus or minus 1, and I'm going to add 6 to both sides so that I end up with two situations. I could have positive 1 plus 6, in which case v is equal to 7, or I could have negative 1 plus 6, in which case v is equal to 5. And those are my two solutions. So this process is called completing the square. This is how we can take an equation that is in standard form, or something that is pretty similar to standard form, turn it into something that looks approximately like vertex form, and then solve by taking a square root. Practice hard, study well. Good luck, my friends.